Hello, hello, hello. All right, you should be able to hear me. I'm going to be going over my Sprint 2. This is my Sprint 2 folder email that I'm going to send you. Let's hop on over to Unity. So I'm currently, it's really annoying. My computer specs are not great. So what I did for my Sprint 3 submission was I strictly game recorded. But when you're game recording, you cannot freely move around tabs or windows. Um, so I'm going to be focusing predominantly on the scripts within Sprint 2, and I think that'll be good because the gameplay is nothing special, and there is no gameplay loop, and there's no objective since this ended up being scrapped. Um, to give a quick rundown, I talked to Professor Sakura. It was not a great time, that I was going on with what was going on with life, and I was disappointed that life got in the way with schoolwork, and I don't believe it's any excuse, but I want to make sure I still submit something for Sprint 2. So I'm going to be going over these scripts, which are predominantly, again, from Sprint 1, but I could explain potentially this script is a custom script, and yeah. You'll find that a lot of my more complicated logic is contained within Sprint 3. There's a lot more physics-based logic that needed to be written in Sprint 3, as well as, um, yeah, just generally more bulkier with everything being serialized. Um, yeah, more objects to write logic for, and a little bit more complicated ideas with raycasting for connecting and flicking the player, as well as I'm talking about Spin 3 right now, but as well as instantiating prefab clones for the enemies. So with that aside, and I actually also did some of a script to try and reduce the amount of um, memory that was being used in the program to increase the frames. So anyway, let's get started. I'll open up the camera controller script. Should see Microsoft Visual Studio popping up. This is yeah, this is going to be what's controlling the camera. So this is commented out because what I ended up doing was utilizing the first person controller script and prefab. And this was no longer needed, but basically all that was happening here is we were calling our player game object and a vector 3 for an offset and um, transform to position subtracted by player dot transform position. So we're creating this offset by finding the transform position subtracted by the player, their current transform position during the start. And then every update frame, we're getting that transform position and we're setting it equal to player.transform.position plus the offset. So this logic is no longer being used, but let's shift through some other scripts. This is a color transition script. I like this one. I put this on, basically you target a material and you interpolate through an array of colors that are contained within the material's color wheel kind of selector area of the component. So you basically create an array of colors that you select through, and you attach that to a specific material, then you call it material, and it'll look through each color. You need to create a target point, and this is just standard for any time you're lerping. You need a start and an endpoint that is um, relevant to the game running time. Otherwise, your start and runtime don't mean anything, which is something that throughout many projects I actually like really it took me a while to understand, specifically for a first person shooter game I was running. I wanted to interpolate the FOV And I was just thinking that I could set like these static values don't really mean anything. They're just, oh, a floating point value. But no, you need to capture a point in the running time of the game, and that's your reference to when you start interpolating. And then you need to capture an endpoint or a target point that needs to be typically not always not a dynamic point. You want it to be a static point, but typically something that is referencing um, like the player camera of some sorts. So that was quite interesting learning how to lerp. So yeah, we create a target point and we're gonna just set that equal to plus equal to time dot delta time, which is the change of the current frame subtracted by the last frame to keep a constant running clock essentially to prevent stuttering because we know that computers are all running at different FPS or they're not consistently running the same amount of calculations per second. That would be kind of like illogical to think that your computer's constantly running at the exact same speed regardless. It's kind of always, task dependent and um, a lot of moving factors there. So basically, we reduce the hardware lim limitations, right? We reduce that into time dot delta time. And then we subtract it by our current time. Time being the time of the frame. Actually, no, time being just a floating point that's not set to anything here. So then we are going to call the material dot color. This is where we're targeting material. And we're going to lerp through, this is typically A to B at rate of t. So colors of the index of our current color, this is what I meant by the array. Um, in all honesty, I'm not actually, yeah, no, this is an array. It's kind of weird because I'm so used to Java's arrays, um, which are still pretty similar, but then you just throw in the fact that we're using this color array, which is like very interesting to see, is we're used to like creating array structures of type, integer, string, float, things of that nature. So now we're, you know, capturing an array of colors, which is cool. So we start with that first color array. And what we know, excuse me, and what we know is that the first array is always 0. So that's why we're able to just capture that first array. And we also call it right here. We know that in Java and in C Sharp and any programming language, typically the first index on array is 0. Then we move on to our color, our target index. Um, so we're getting colors, target color index, which is 1, which is kind of interesting because actually I guess it doesn't matter what index it is because because we're confined when we're lerping from a point from 0 to 1. So typically, and then our target point is again that running clock. So we're just going to continuously interpolate depending on our the time. So it's going to loop over and over again. We see there's no typical exit. We're just running if target input is not equal to 1. This is the kind of the weird looping structure here. If our target index is not, greater than or equal to 1, we know that we haven't reached 1, which is the end of the index of colors. So we enter the loop. We set our target point to 0. Um, Current color index is equal to our target index to reset, and then we start incrementing again. And we check if the target color index is equal to the colors length. Our target color index is back to 0. So yeah, that's and we contain this in our transition. Um, So, and then we take this method, this transition method, and we throw it in our update. And we don't need it being fixed update because we got time.delta time right here. Very cool. So let's move over to our rotator script. This is super basic script. This was actually also somewhat implemented, but on this is, I believe, one axis. This we're directly manipulating the transform. I utilize something similar to this inside of my on a much more minute scale on my Sprint 3 project, where essentially I set the vector 3 of the squares above I wanted to keep theme, so I basically set a square above the goal nets, and I did something similar to this, but I manipulated it on two axes, I don't know, two axes, um, to rotate it, to give it a little different look. But regardless, we're just calling transform.rotate new vector 3, colon 15, 30, and 45 to spin it around. And we're multiplying that by time.delta time to prevent stuttering of that transition. Very important. Enemy movement. So this is our first taste of nav mesh. Very basic script again. Pull in our transform of our player, pull in the nav mesh agent that we have. These are the two things we need to instantiate here or create these two objects. In the start, we need to load up our nav mesh agent. We need to get our component because we're manipulating this component. So we call nav mesh equals get component nav mesh, and we don't need to do the long-handed writing statement for the nav mesh since we have it right here. So we know what nav mesh is. Sometimes we would do like rigid body RB equals get component rigid body, right? Like that's just the longhand stated way of writing it. But to be honest, I don't know if it really means anything. For C sharp, that's a good question that I want to know if it really means anything to not write it out fully in the start method. Here we're getting the added benefit of making this private variable, which means it's going to be limited to this class right here and this namespace. Assumably, I still don't know what namespaces fully mean, but limited to this namespace. And yeah, I don't know if there's any benefit, but I'd love to know. We're gonna call the update every frame. We do not need to necessarily worry about time.delta time in this instance. And we just say, oh, if our player object is null, not null, then all right, let's set destination of our nav mesh agent to our player position. Extremely basic. We saw in the pet script, and we will see in the pet controller script in a second, the similar logic, but with a kind of like a I believe vector 3 preventing it from staying a certain distance away. It'll follow, but it will not to a certain distance. That'd be this vector 3 right here. Okay. So we have public transform calling our player, calling our nav mesh agent again. This is going to be for the pet. We need to keep a variable for a follow distance, which will be 2.0 float. We are going to, in the start method, we're going to get our components again. Same thing. If our nav mesh agent is equal to null, this is a debug log. I guess when I was trying to figure out what's going on with it. This is just going to output to the console our nav mesh agent if it's not instantiated into the game if it's not there. So it's fine. And then we now have our update. Same thing. If player's not null and our nav mesh agent not null. So we need both our player and our nav mesh agent. The amount of checking might not be necessary, but I guess in this case it's fine because if you wanted to add a logic for the agent, then you make sure that the player's alive, obviously, but you also make sure that the nav mesh agent wasn't deleted, so you don't have some weird bonky logic going on where the nav mesh agent might have been destroyed or the nav mesh agent might have been in some way not like removed but not fully. So not the worst check. So then we set a float distance to a vector3 dot distance, which is going to take 2 points between A and B. So we have our player position. This is going to be this vector3 in three-dimensional space. I'm presuming is since it's only 2 points and we're in a three-dimensional space, we are basically setting, I guess, a radius around the entire player or whatever we're trying to call with this distance variable. So if our player is, we check the whole 3D radius around the entire player using vector3.distance. And we call the player's position, and then we call the transform position. And we check if this distance that we set before um, is greater than the follow distance. Then we're setting our nav mesh agent to set the destination to the player position again. So I think what happened here is we see that if you wanted to write even more precise logic on how the pet's manipulating, rather than set it to the player with some kind of like margin of, hey, you cannot go into this area. What we're going to see is um, the agent is going to go to the player. It's going to say, oh, wait, our follow distance is 2. I can't go that close. It's going to stop. And then not until the next update loop, it's going to re-enter. So perhaps instead of writing logic that's continuously following the enemy, we're going to see, as we saw, if we load this code up, we're going to see the player move, and then depending on the speed of the enemy, then it's going to catch back up and start heading on towards the player. Maybe a more better approach to this would just to simply set the pet transform equal to the player transform with an offset, and where it's not heading to the player transform, but maybe it's just remaining at a certain margin's length as a perhaps making the pet a child of the the player, and that might be also more beneficial as the movement of the player will be more immediate with the movement of the pet, and you don't need to worry about setting crazy fast speeds to give this illusion that it's kind of more glued to the side of you as a player. So maybe that would have been a better approach, but you could potentially lose the ability to control it as an agent. But I digress. I think this could always be modified and edited, and a lot more to look at here. So this camera controller should do that. It's not utilized. Player controller. This was the original player controller for um, um, Sprint 1, which is I could go for it word for word. We're just calling rigid body. Get the component of our rigid body. Set a count, set to 0. This one's start. There's actually a lot going on, but if we look at what's privately and publicly declared here, we have rigid body, likely the player rigid body, the private count. I'm not sure what that's for yet. I don't remember, but we have the float, movement X, movement Y on both of our axes. Oh yeah, we need to call these two floating point. We need to declare these for the movement that's going to be applied to the force, and we need to be able to dictate which axis that movement's being applied to. We have a speed set. We have a this count and win text. It's a game door object for destroying on a certain count, and then this is the time showing. Not sure what the time showing was for. On start, call that get that rigid body component. Set it. Set our count to 0. That's typical for any kind of timer object that's going on in the game. Set count text. Call that method, which we'll see later in the script likely. Set text setup win as false start. Win text games the active we want to make sure our win state is set as false. That way it's not being displayed immediately, and then we could either activate. We're essentially activating that win text on a certain condition. On move, we're inputting the movement value by putting a movement vector here. We'll call it vector 2. Or I'm sorry, we're getting this component. This is vector 2. So a two-dimensional movement input going on here. There's a movement x and movement y, which just says movement vector x and movement vector y. Set their count. This is a method to help set count if our pickups are greater than 12. Our text right here count, and then rinse or what's the terminology for it? Concatenating. I don't know if you'd consider this concatenation inside of this is concatenation in Java. I'm not sure if it's in C#, but concatenating our count.toString. So we need to grab our count, which is an integer, and convert it to a string to render and normalize our data into strings. If our count is 12, and we're going to then display that we're going to set that message when to true. And this is a little coroutine that I created. This is when I first learned what a coroutine was, which typically has 2 components and can get wonky pretty fast. You'll need a coroutine, and then you need an I enumerator, which I still have no idea what an I enumerator is supposed to mean, but I know its intended use is. But I was like, okay, well, how can I set a certain amount of seconds for something to happen and delay it? I believe the way an enumerator works is it sends off to a separate thread to be handled, or something along those lines where your loop is continuing, presumably, right? If you called some kind of like way to stop, or if you wanted to put this into a while loop, while time is less than 3 seconds, and you're gonna immediately blow up your program, and it's going to freeze for either 3 seconds, or you're going to crash because whatever exit condition on that while loop. While loops are scary in game development, I will say that. But regardless, we don't want this really fast game loop to pause in any sense. We want it to continue and load our game, so we call this enumerator, and that's going to, I guess, separate the logic from what's being delayed to happen here, and normally set a some kind of floating point value. Here it's just 5, um, and we yield return new. These are all keywords that I found on the YouTube video when I was learning about this. Yield return new, and then we call wait for seconds of 5, and that's going to wait for 5 seconds. And we don't need to worry about converting. We don't need to worry about time dot delta time. Going to wait 5 whole seconds, and then it's going to display our win.game object set active false. So what this is doing is we've set it true, right? On this count, when we enter this loop, we set it true. It's displaying. Hold on, wait, we're starting our coroutine. We don't want it to remove immediately, but we don't want our set count text to just sit there in the middle of our screen where we just want it off our screen like a bug, like on our screen. So we send it to this coroutine that calls this enumerator. Yield return new, wait 5 seconds. We're waiting. 5, 4, 3, 2, 1. Removes the win text by setting it to false. And that's our code routine. Pretty cool and very, very useful in timed events. Probably really used with UI and probably animations as well. So that's a cool thing that I learned. Private void fixed update. This is our fixed update, which is going to normalize our frames. We're going to call a vector3 movement, and we're going to set that to our movement x, a float of 0, and our movement y. And we're also going to then here we're applying our force to our player here by calling RB to that component, add force at movement times speed. So here, call the movement vector, right? And on X and Y, which are above here, which is a vector 2. And then we insert them into our vector 3, and we do not need to worry about our just Z. We don't need to worry about all three axes, presumably. I don't want to give me an error. I wanted to see the context of what it wants, but I'm assuming it's just another vector. It's just another axis. But we don't need movement on that axis. We just need movement on X and Y, and that handles it. So, in the sense that our object is a ball. Now, if our object wasn't a ball and it was a more, collider in which it's not going, or a mesh and a collider that's not going to be rolling, then you would likely need to worry about, I believe it's X, Y, and Z. So you probably need to worry about the Z axis. But in this case, we could apply force forward or on the y-axis, and that's going to start rolling. So that's what's going on there. This is a trigger collider. This is a nice little method, very basic, and explains a lot, and is used very frequently whenever we're trying to get triggers to happen on a trigger ender, which means inside the component, the trigger button needs to be checked on, which makes it so that this object is typically going to not obey physics. A lot of people probably ran into the issue where you click that is trigger a check mark, and then your object is applied to gravity, and it is kinematic and has a rigid body, and it falls through the map. And that's just what is trigger does. But is trigger is important for making sure that collider, whatever collider shape it is, when another object comes into contact with it that contains a rigid body, that way you can, well, it doesn't. I guess I don't think it needs to. It doesn't need to have a rigid body. It could just have a collider. But when another object, the collider, comes into contact, get, we're able to create this method so that it's going to take in anything else, which is other. We check if the object the player collided with has the pickup tag. So this is our checking to ensure. You can do this with layers as well. For my project in Sprint 3, one of the weird things I did was, since the stadium was this big prefab, one of the issues that I ran into was my raycast that was being shot to my mouse, which was basically controlling when I clicked on the player. That was being blocked by other colliders, the walls, which I wanted to be high up. And since this is a third person view angle of the camera, what essentially ended up happening was that raycast to the player was not being triggered. So what I needed to do was I basically was able to, um, in this instance, I wouldn't need to check the tag, a way of like filtering. Tags are important, don't get me wrong, but a way of filtering, I guess, that raycast was just putting the walls on a ignore raycast layer. So that did the trick, and there's a way to target your objects and target to make sure that you're able to interact with what you need to interact while ignoring and remaining functionality with things like the walls. Because the walls need to be up high and they need to still hello, hello. All right, so my headset died. We're gonna keep going, keep trucking away. We're almost done, and hopefully you could hear me a decent amount. So let's keep going. Where I left off was we're checking our tags, and if this tag is the pickup tag, which we could declare within here, we go to pickup parent. And pickup parent will have our pickup prefab, and we see the pickup tag. So if this pickup tag is directly word for word what we're targeting, then it's going to enter this loop, deactivate the collided object, as we see here with other.game object, which is this. We set it to false, increment our count for the managing the win and the rest of the UI, and then if our count is equal to 12, and again this was the door logic. We could just check within this same fixed update loop that if our count reaches 12 for the pickups, then deactivate our door, and that would, if I had more of the level, we'd progress throughout the level, and that's a way of hindering level progression and making a reason to continue playing and open up new areas of the map potentially. This is the first person controller. This is pretty complicated. Do I have time to go through everything? I'm not going through 700 lines of code. If there was something I specifically wanted to interact with in here, I'd be able to find it. But everything's very neatly organized on this. It's more making sure that the update methods are, if it's fixed, late, delete, whatever, if we need it, that's an important thing to check, especially when you're utilizing just something I got off the asset store, especially with the rest of the objects. So let's start. We're setting count for something. We're checking if our cursor is locked, if it's in a locked state. If our crosshair sprite, we're creating that on start. We're just setting it to true initially. This is all just set up. Setting our FOV, invert camera false. Likely if you wanted to invert the camera, camera can move true. A lot of checking. These basic Boolean values. Just a lot of basic Boolean values. I guess for more power to the user who's taking in this asset, this first person controller asset. Everything's enabled. Key code. We're hard coding our crouch key. When I've had other larger projects use Unity's input handler, which essentially you create parameters for your controls, and those controls could have different meanings depending on the inputs that are being put in. That's pretty cool. There seems to be like this little region for this head bob animation that is physically affecting this vector 3 with these tiny floating point values. Maybe make a little bit of movement, visible, just some nice added touches. On a wave, we always have to call that rigid body component. Set our FOV, these internal variables, our original scale, join original position. Not sure what that's for. If not, unlimited sprint. I guess you can modify the sprint values so that there's a limited amount of time that you're able to spend holding down the shift button. If you go to definition, yeah, unlimited sprints false. There might be, is there any kind of, yeah, let's see if there's any kind of logic around unlimited sprint. So handle sprint bar, if sprint bar and not unlimited sprint remaining percent is equal. So this is only going to be if unlimited sprint is set to false. Then set this floating remaining percent equal to sprint remaining divided by sprint duration. Sprint dot transform local scale equals new vector 3 sprint remaining percent. I guess this is just a way of calling how long you're able to be sprinting depending on these conditions right here. A little abstracted. I'm sure there's a reason, but it's not coming to me just yet. Continue. Is there any other FPC? First person controller. So we're referencing first person controller. Editor GUI load up to element sprint determines if it's. So this seems to be just like the UI, the graphical user interface that's seen in the inspector. Since I guess these things aren't serialized and you cannot directly modify, but there's probably some kind of context somewhere where I'll explain each component. Yeah, so we're creating a custom editor. Um, yeah, I haven't had a lot of experience with this, so. But yeah, there's a lot going on here. This was imported. I know you guys don't 100% care for the explanation of someone else's code, especially with 700 lines long, but something interesting. Shadowcaster 2D. This is just, I believe, Unity generated miscellaneous files. So that's this whole Sprint 2 project. I will stop blabbering away. Yeah. That is a code review on our Sprint 2. I would run it, but I know it would stutter and not be an enjoyable experience and potentially corrupt all the files. So I'm going to stop recording now. Thank you very much for watching, and yeah.